is our solution notes number 1 that we did on March 28th. We did an activity diluting or making a solution of Kool-Aid and water. That's what this information is here, talking about the activity, that the parts of the activity that goes with the definitions. So our first definition is a solution. This is a homogeneous mixture, and you cannot see the parts. That was our Kool-Aid. We added water and Kool-Aid powder. The solute, that's the part that gets dissolved. This was our Kool-Aid powder. And it was dissolved in water, in the solvent. The solvent is the part that does the dissolving. Soluble means it dissolves. That was the powder in the water. Insoluble means it does not dissolve. That was the oil and water we added on top. The definition for solubility. This is the maximum amount of solute that can be dissolved in a given quantity, 100 grams usually, of solvent, which is usually water, because water is known as the universal solvent, at a specific temperature. For example, 45 grams of strontium nitrate, I didn't finish writing that formula, and 100 grams of water at 35 degrees Celsius. So it should look like that. The solubility graph, which is the graph on back, is the graph that compares the amount of solute to the temperature. Okay. And when we talk about 100 grams of water, 1 gram of water is equal to 1 milliliter of water, because the density of water is 1 gram per milliliter. So what determines what will and will not dissolve? Our rule is like dissolves like. And when we refer to like, we're talking about the polarity, the difference in electronegativity. Polar dissolves polar and ionic substances because these guys have charges. If you remember when we learned about water, this oxygen has a slightly negative charge because it attracts one of the shared electrons more than the hydrogen can. So it's not an equal sharing. Nonpolar dissolves nonpolar, and these are equal sharing of electrons. So water, which is very polar, dissolves polar in almost all ionic substances. Nonpolar would be benzenes, oil, gasoline, and that's why we mix oil and gasoline together for our motors. Okay. When ionic compounds dissolve in water, they will conduct a current. These solutions are called electrolytes. Conducting a current will not occur with nonpolar substances because they do not dissociate. And if you recall, when we learned ionic compounds, the sodium chloride, all of our ionic compounds break up into their ions, or what we call dissociate. Covalent compounds do not. The more particles or more solute, the stronger the electrolyte. So then we look at which of the following would separate into their ions. Ammonium chloride. We have 1 ammonium, 1 chlorine atom, so that would have 2 particles, because 1 plus 1 is 2. Nickel, there's 1 nickel and 3 chlorines, so there'd be a total of 4 particles. Glucose is a covalent compound, so it would never dissociate in water. Calcium oxalate, we have 1 calcium, 1 oxalate, so that would be 2. Strontium nitrate, we have 1 strontium and 2 nitrates, so 1 plus 2 is 3. The next thing we learned about with solutions is the saturation levels. The saturation level is like a 3-layer cake. The bottom would have just 1 layer of icing. We'd call that unsaturated. The middle layer would have icing on both sides, so that would be a saturated solution. If we added any extra, it would come out of solution, or it would sink to the bottom. The top one would be supersaturated. It has all this extra icing on the bottom. It would be too much. So our definitions are an unsaturated solution. There's more solute can be added. And saturation levels depend on temperature and amount of solvent. Saturated means it cannot dissolve anymore. Solute, the excess will sink to the bottom. And this is like our iced tea at a restaurant. So as we add the more sugar, it just sinks to the bottom. Because it's cold, it can't accept anymore because saturation levels depend on temperature and amount of solvent. Supersaturated solutions, and that's like the demonstration I did in class. The supersaturated contains more solute than it should. It's unstable, and the extra solute will precipitate out of solution. You're going to do a project of rock candy, and that's a supersaturated solution. When reading a solubility graph, if the solubility given or the data point given is on the line, it's called a saturated solution. If it's below the line, it's an unsaturated solution. And if it's above the line, it's supersaturated. So let's look at the back to see what we're talking about. So on the back, this is our solubility graph. We have two lines, two different compounds that decrease as temperature increases, and that's because these guys are gases. Just think about your Cokes. You put your Cokes in the refrigerator to keep them cool, to keep that gas into the syrup that you use to make your Cokes. Then we have potassium iodide, sodium nitrate, potassium nitrate, sodium, oops, did I get the line? That's the wrong line. Sodium chloride, sodium and chlorine, ammonium chloride, potassium chloride, and potassium chlorate. Of course, there's many different types of solubility graphs depending on which substances you're looking at. So in our homework, which substance seems not to change greatly? Which one doesn't change much out of these? It would be the NaCl. Which substances appear to decrease in solubility? So which substances appear to decrease in solubility as the temperature increases? That would be our two gases, ammonia and cesium sulfate. Which substance appears to increase the most as temperature increases, so that it would have the steepest rise? Our potassium nitrate. Alright, and so for your homework, what we were doing is just answering these questions. Which two substances, let's go to this one. At 50 degrees Celsius, what is the most KNO3 that would dissolve in 100 grams of water? So we're at 50 degrees Celsius, we found the KNO3 line, and it would be 80 grams. Okay. So if you have any questions, just email me.